So this is the document to help us organize important information regarding systems of equations. So you can see that on the left-hand side, we have the main idea, and over here, notes or examples. So systems of equations are really where you have two or more linear equations with the same variables. And what you're trying to do is you're trying to find an XY coordinate pair that will solve the equations. Now, most of what we're going to be doing is just going to be involving two equations, but you actually could have three, because if you think about it, on a coordinate plane with X and Y axes, you could have more than one line going on, and they could all intersect at the same point. But typically in the examples we're going to be doing, it's only going to be two. Okay, so the solution to a system graphically, that means if you put it on a coordinate plane, is the point XY where the two lines intersect. And algebraically, that point will make both equations true. And again, they say both, but it would be all if you had three. So the words we want in here are intersect and true. However, there's three different types of solutions that you can actually have. The intersecting lines will result in one solution, and that is the coordinate pair x comma y, whatever those values end up being at this point here. So this is xy. However, when you change the equations into slope-intercept form, you might find that the lines are parallel. And in that case, there is no solution. So if you get that situation where your slope is the same for both lines, without even graphing it, you'll know that you'll have no solution because they will never intersect each other. The last one is where the two lines actually represent the exact same line. And so when you graph it, you're going to have two lines that overlay one another. And I believe I did this in Desmos for the class, Elijah, so I will share that link with you. So if you want to look at it, you can see it. And in that case, there would be an infinite number of solutions because this one line is actually also the other line laid on top of it. We could actually highlight another line laying on top of it. So this is actually two different lines, two different equations of the same line. So in that case, we would say there's infinite solutions. So how do we solve systems of equations by graphing? Well, if they're not in slope-intercept form, we rewrite the equations in slope-intercept form, and then we graph both lines, and then we identify which solution we have. Do we have an XY coordinate pair? Is there no solution because the lines are parallel? Or is there an infinite number of solutions because actually the two equations, when written in slope-intercept form, are the exact same equation? So down below, what we did was we graphed the lines representing y equals x minus 8, which we changed to plus a negative 8. And we talked about the fact that there is a little 1 in front of that x, even though you don't see it. And the next equation was y equals negative 2x plus 1. And so we knew that when we looked at the slopes, 1 and negative 2, they are not the same, so we're not going to have parallel lines. And we were able to find points to start with each of the lines. So for this first line, we saw that the y-intercept was 0, negative 8. So we came down and we found 0, negative 8 and put a point. And then we saw that the slope was 1. So we went up 1, over 1, up 1, over 1, and then we connected those dots. So this is the graph of the line y equals 1x plus negative 8. Now Anna said the way she solves this and finds another point is she sets y equal to 0. So we did it that way as well. And we said, well, what if y is equal to 0? That would give us x plus negative 8 equals 0. So then we knew that x had to be 8. So we said, well, when x is 8, y is 0. So that's why this point is way up here, because that's how Anna solved it. But you see, we could continue on with up 1, over 1, up 1, over 1, up 1, over 1, and we should end up there. Maybe I counted wrong. 1, 2, 3, 4, 5, 6, 7. Nope, that's 8. So that's this line right here. The other line has a slope of negative 2, and it has a y-intercept of 1. So there is that. And then we use the slope. We went down 2 and over 1, down 2, over 1, down 2, over 1. And when we had 2 points, we were able to connect. And so we saw that the intersection was right here, and that point is our solution. And that was 1, 2, 3, so that's our x value, and negative 5. 1, 2, 3, 4, 5. So the solution set for this using graphing is 3, negative 5. So if we're to look at the next one, which we didn't do in class, but I'll do it with you. One of the things when we look at slope-intercept form is we can find a point for each line by looking at the y-intercept. So these are both in slope-intercept form, which is great. So I'm going to start with this one, and I have 9, and that means that, by the way, these are each in groups of 10, so I know that this would be 9. So this is going to be the point 0, 9. And then using my slope right here of 1, 2, I can say up 1 over 1, 2. And there's my second point. So then connecting those, I can see that my line, I might draw it a little longer if these intersect. Here's my line for y equals 1/2 x plus 9. So looking at this line, I know that my y-intercept is at 6 on the y-axis. 1, 2, 3, 4, 5, 6. And I can see that I'm going to have a negative 1 for my slope. So that's down 1 over 1. Down 1 to the right 1. So I have some points and I can connect those. And I can see where my point of intersection is. I think it's supposed to be right there. I think this line I didn't draw quite correctly. So it should be at -1, 2 for my x. And for my y, it should be 1, well, I know this is 6, 7, 8. Now, what I can do is I can put this solution set back in these equations, and when I put in the x, I should get the y. So when I put in -2 right here, I should get an answer of 8 for y. And the same thing for the second one. So let's see if that works. Y equals 1/2 times my x is -2. And I'm going to put that over 1. And then plus 9. So when I cancel both sides by 2, I can see that I have 1 times -1 over 1 times 1. So my y is going to be equal to -1 plus 9. And when I solve that, I see that y is indeed equal to 8. Checking it out with the other equation, where I have y equals the opposite of x plus 6, that means that y is going to be equal to the opposite of whatever x is. And x in this case is -2 plus 6. So a negative times a negative is a positive. And I am going to get y is equal to 8. Now I could have substituted in the 8 here and solved for x, but I chose to put the x in and solve for y. So you can see that it does work. This pair is a solution set for this line and for this line, even though they're not the same line, because they intersect and they share that particular point.